Thank you. Amazing. Cool, cool, cool. So I want to start the talk by saying something. The talk is called How to Teach Your Computer to Play Guitar, but it's actually going to be a talk about parser combinators. So I just lied to you, but just give me 5 minutes and I'll convince you that parser combinators are amazing. Cool. Hello. My name is Ju. You can find me online as Arkham with a 4, and I work for this company. I like to play the guitar. I'm not very good at it. So usually what I do is that I look up songs on the web. But those webs are dark and full of terror. So usually you're looking for these songs. So basically there's like these chord sheets for how to play a song. And usually they look something like this. So you have these square brackets, and inside the square bracket there's a chord, and then you have the lyrics. Yeah. So for example, you can see the first chord is an A minor, and then there's some lyrics, and then another chord, some more lyrics. And usually when you're trying to pick up the song, you're supposed to play the chord right where it's there, and then you start singing, and so on and so forth. This is usually the content I'm looking for. But most of the websites, I won't name them because I'm too kind, but most websites that have this content, they look something like this. They have auto-playing videos. It's just something quite embarrassing, frankly. And, you know, as a software engineer, I just thought, it's fine, I'll just do it myself. You know, how hard can it be? I have like this blurb of text. I'm just going to write a quick program. It's going to parse it and everything. And it's going to be amazing. And, you know, parsing a blurb of text, we know the answer, right? Yeah? Okay, so I just want to, this is the last slide of the talk. And it's a regular expression that is able to describe a chord. You can see there's a special character, which is the backslash, which says that this is a special character. And it's like the opening square bracket. And then you have the notes from A to G. And then you have this optional lowercase m, which denotes if a chord is a major or a minor chord. I promise I have all the slides, but I'm not going to use them. They're there, you can find them, whatever. Okay, I don't want to upgrade DexSet right now. We're going to do some live coding. Cool. Woo! Amazing. I have like a little bit of code prepared, but just to show that I'm playing like a fair game, I'm going to use some helpers. So I'm very much inspired by the Harry Potter world. So all my helpers are called Accio something. So I'm going to do Accio Elm, and this grabs an Elm program. We don't really have to care at all about what Elm is. It's like a functional programming language, compiles to JavaScript, whatever. We just care about this view function, right? So we have a model. Right now it's like an empty dictionary, an empty map, an empty object, and it emits some HTML. And I've hooked up a little bit of machinery that auto-recompiles this. So I can save this, and for example, I can replace this with WebCamp. And you'll see it says, of course, like maybe, yes, thank you. And it says, you know, just like auto-recompiles on the fly. Yeah? Awesome. And I'm going to grab one of those sheets that I was telling you about. So it's Accio sheet. And you see it's the same song. I'm trying to exit Vim, but not letting me. And here I'm going to do something simple, which is to grab this sheet, which is like this huge string, and split it into lines. So I'm going to say lines equals string.lines sheet. Yeah? And you don't have to worry if you don't understand like most of like what it says. I'm going to describe, you know, talk through most of it, and then in the end you'll have like a live editor where you can play around with the code. It will auto-recompile, and you can, you know, just have fun with it. Okay, that's the other room. I thought it was like someone like, you know, heckling. I was like, oh, interesting. So I'm going to use some helpers, and I'm going to go through over these lines. And for each line, I'm going to create a div. For each div, I'm going to create a span. And inside the span, I'm going to put the line. And I'm going to give it a CSS attribute, which is a class line, right? And if I save that, it recompiles. You can see we have our sheet on the right. Right? And this is like something that we'll see all the time. Like I will save, and if I see some red in my editor, it means I made an error, and the compiler has caught the error, and it will tell me exactly where the error is. But if my editor tells me you're good to go, then I'm pretty, 100% sure that the code on the right works. Maybe not 100%. That's like a bit arrogant. Let's say like 90%, right? And we can see that now our program has taken this thing, has split it into lines, whatever. So now I'm going to grab the regular expression that we're talking about. And you see on the right-hand side, there's like a little bit of machinery involved to grab the lyrics. But, I won't bore you with that. And then I need to import the regex package. Yeah? Once I've done that, then I can run this regular expression. So I can do a case. So this thing is going to return. Maybe I'm not going to do a case, actually, because I don't want to do too much work, really. So I'm going to do a regex find of this regex. I'm going to pass the line that I had before. Oh, no. I don't really know what this came from, but it's fine. I'm sure I can just fix it. Line here. Cool. Regex find line, amazing. And here inside this, I can just pipe it to a function, which I've prepared in advance, which is called viewRegex. Yeah, cool. And I'm going to atcho that as well. Atcho viewRegex. And this is doing something like quite simple. It's like running this regular expression, it's figuring out all the matches, it's adding a CSS class, but that's all. And you can see, whoa, it worked. Yeah. So if I inspect the DOM, you'll see that it has successfully worked. Maybe this can be bigger, too big, but yeah, whatever. You see, this is a token, and there's like A minor, and then there's some lyrics, then another token, and so on and so forth. Yeah. What is the problem of that? Is that I spent time writing this regular expression. I ran the regular expression. The regular expression worked actually, which is not something that happens all the time. And now we got a program that can tell us that in that AM, there's a chord. But if I want to ask the program, like, what chord that is, the program doesn't really know. The program says, look, in that piece of string, I'm pretty sure there is a chord. But then me, as the programmer, have to go back out there and figure out what chord is that. I have to figure out that that is an A minor, right? So I did some research. So there's like a lot of like JavaScript libraries that do this sort of operation, and they do exactly this. So they run this huge regular expression because the one I've showed you is just for very simple chords. But musicians, they have lots of chords. And you end up with this huge regular expression, and then that is followed by custom parsing logic, right? So what we're going to do today is to cut the middleman. So instead of having to write a regular expression and then do more work, we're just going to write something which is very similar to a regular expression, but does everything like in one go. Yeah? And that's what I mentioned before, like these scary words like parsers or parser combinators. Like if you spend enough time in the functional programming world, like you'll probably hear of them. And like in my opinion, they're pretty cool. So I'm just going to import this library called Parser, and I'm going to say P. And just for fun, I'm going to expose all the functions here so that I don't have to necessarily use the namespace. Cool. So the amazing thing about this library is that we're going to build something that parses a chord, right? And there's a type which is a parser type. And this parser type needs something. But the problem is like, this is all the code, so I don't really know what I need to parse. So we're going to do some wishful programming. So I'm going to say, imagine this great world where I have a chord. I'm going to parse it, yeah? And then we're going to say, okay, now let's define what chord is. And you're saying like, a chord is something that has a note, let's say like A minor, right? It's a chord that has a root note and has a quality, right? So I'm going to exactly write that. And I think this is a weird way of like writing programming. Usually you program with stuff that you have, but now I'm writing code with stuff that just I wish was there. It's not there, but I'm going to fix that real quick. So I'm going to grab the note, atcho note, And you can see that it's the same notes we had before. So the 7 notes like in the Western representation of musical theory. And then I can say that the quality can be either major or minor. Yeah. If I save this, you'll see what Elm tells me. Missing definition. There's a typo notation for Chord Parser, but there's no definition, right? And this is the quality of errors that you get all the time with Elm. Like you get like these nice, humanly readable like messages, not weird like compiler sec trace. And we're going to build a very simple parser, which is going to return all the time my favorite chord, which is A minor. So I'm going to say P succeed, chord, A minor. Cool. And now you'll see that this compiles. And I haven't changed like the view code, so it's still like printing out the regex stuff. But basically the thing is like very similar. So I'm going to replace this regex with p.run. I'm running the parser, and the parser is called the chord parser, and I'm going to run it on this line. And this thing can have 2 possible return values. It can either be everything is great, and it will return the value, and this is like okay value, or it can be an error. So when there's an error, it will tell me what the error is. Yeah. And in both cases, right now, since we're just playing around, I'm just going to emit like some HTML text. I'm going to print out the value, and here the same HTML text, and debug the error. Yeah? And if I run this, you'll see, wow, we have like this great parser. It said, okay, I found A minor all the time. It's not very useful, but it's pretty cool. And just to make the life of this thing easier, I'm just going to simplify the input. So I'm going to put some, A minor, then I'm going to put C, then I'm going to put like F minor, and then I'm going to put G, right? Just like some simple chords. But it doesn't matter, like right now, like the thing is like, oh, A minor all the time. Cool. So what I want to do now is to here, instead of always hard coding A minor, I want this function to take 2 values. And one is going to be the note, and the other one is to be the quality. And with these 2 things, I can build the chord, right? I can do chord, note, quality, right? And now I have to combine multiple parsers, and this is the main idea behind parser combinators. Like you want to write smaller parsers and reuse them all over the place, which is really hard to do with regular expressions. I'm not sure if you've tried, but you can let me know like if you have like success stories there. And so I'm going to do that, and I'm going to use this weird operator, which I call a left Hadouken operator. And it basically just does something simple. So it tries to parse some input, and if it manages to grab something, it will send it up. So you can see this is exactly the same order. I parse the note, I send it up, I parse the quality, I send it up. And as a just quick refactoring, actually when you define a type like this in Elm, it will automatically define a function like note quality, chord note quality, which is just chord. Not very exciting. And now we can move on to build what a note parser is. And a note parser will have to try multiple ways, right? Like you will have to try to go through all the chords. So one way is to say, if you meet a symbol, which is like capital A, then that's the note A, right? So I'm going to write exactly that. I'm going to say P succeed, A, whenever, and these are another operator which I call left pong operator, when you match this A symbol. So it means when you match this A symbol, just return this A thing. And I'm going to do this for all the notes. So I'm going to do it for G, I'm going to do it for yeah, thank you. And I'm going to do it for C, okay? And if I save this now, it will say like the code gets auto-formatted, and the error becomes, I cannot find the quality parser variable. Cool, so let's do that. Quality parser is a P one-off, and this is going to be a succeed of minor, wherever we match that lowercase m, right? So it's like exactly the same structure as our regular expression. And instead, if we can't find that lowercase m, like let's say like we have like this C just means C major. So I'm going to do that. I'm just going to say, if you weren't able to do that minor path, just go and do major. Yeah? And like that. as you can see, like, once you've defined these types, and the left-hand side of the editor tells me that the code works, the right-hand side works as well. I think a lot of times when you're writing JavaScript, like you write a code and it seems right, and then you refresh the app and it crashes, and you have to figure out why undefined is not a function. And instead, you don't get this experience. Like when the editor tells me everything is fine. And I think it's quite nice. I don't have much time left, so I'm just going to do something real quick, which is to actually do the thing. Because so far, I've cheated, right? I've said I was going to parse the whole thing, but it's actually just parsing chords. So now I'm going to do and write a line parser. And the line parser, just as before, I don't really know what I'm going to parse, so I'm just going to come up with something. I'm saying it's going to be able to do something like token. Cool. And I don't know what the token is, so I'm going to say, well, I would really like that the token is either I was able to parse a chord, so I'm going to say parse, and this is going to have the value of a chord. Or I'm going to say, oh, it was just lyrics, right? So I'm going to say lyrics, and this is going to be a string, right? And now I just have to implement this. So I'm going to go through the same patterns before. I'm going to say it can be either one of these two things. It can be either be a succeed of a chord. When I successfully, cool. When I successfully left Hadouken a chord parser. And actually, if you think about our sheet, it's not exactly that, right? Because we also have these square brackets. So I have to remember about putting those square brackets in. And that's very easy with the left func operator. Just means consume from the input, but don't really, do anything about it. And instead, the chord parser is going to, this should be parsed. My bad. Cool. And so I'm going to do this symbol, awesome, and this is like the case of chord. And then I'm going to not bore you with details about parser, so I'm just grab this bit about the lyrics. And you'll see, oh no, there's an error. What's the error? It says something is off with the body of line parser. The one-off call produces a parse of token, but the type annotation says you really want the list of tokens. And if we think about it, like before we wrote something that's able to parse a single note, but here, we want to parse a list of tokens. But the way that we wrote the code actually just does one, right? And the compiler knows this and tells me, look, you made a mistake, right? So it is indeed true that I made a mistake. So I'm going to fix that. Succeed, identity, just don't worry about this bit. And I'm going to call this loop function, which does exactly what we want, which is to loop over a parser. So I'm going to create this little helper function, line parser helper. It takes this accumulator. And here, basically, it's very similar to what we used to do before. Instead that return these simple values, we have to return some special values. But it's nothing, out of the ordinary. So I'm just going to say, if you manage to grab a chord, just save it and attach it to this accumulator. And same for lyrics. So if you manage to grab some lyrics, just keep looping and just save these things. And like this, yada, yada, yada. And if the program wasn't able to do neither of those, I'm just going to say, okay, you're done. I'm just going to say done. And I'm going to reverse the accumulator. And this is a very common pattern in functional programming. Like you put things in front of lists and then you reverse them because you're optimizing, whatever. Tail call optimization, Google it. And if I save this, everything is right. Oh, but on the right, something is wrong. What is wrong is, oh, actually, I'm still calling the same chord parser. Unfortunately, the compiler can't save you from that. Like, you're not calling the right code, but everything is connected through the right pipes. So in this case, the compiler can't help you. But if I run our new line parser, and on the line, I can pipe this to a function called view result. And I can just acho that. Acho view result. Awesome. And if I save this, you'll see that it worked. Yeah? And it sounds weird because we just spent like 15 minutes like writing about like this weird stuff that more or less does the same thing as a regular expression. So it seems like a huge waste of time at first, right? But I think the great thing, oh, maybe you can't see it from the display. Oh no, okay, it's just my monitor. is that now the computer really knows that thing is an A minor, and that thing is a G major. It's not just strings for them. It's like an actual token. And that's exactly what like your favorite language is doing whenever you write for or each or for each, right? It's just strings. But at some point, these strings become something of a higher level. And once you have that, you can write a library, which I've done, which knows what a chord is. So if I look for a chord, it knows that, for example, I spent a lot of time on Wikipedia researching this, but you can see that a major note is something that's a root, a major third, and a perfect fifth. And when you have that information, you can convert it to something musicians call integer notation, which is like not surprising, it's the integer notation. And this is the distance of semitones from the root note. And once you have that, then you can build in memory a representation of what a guitar is, right? And the guitar is something that has some tuning. So like this is a default tuning of a guitar. And once we have our chord, we can convert it to the integer notation, and then the code can automatically understand which are the nice chords to play on an instrument. And so on and so forth. So I won't bore you with the details because I'm running a bit out of time. But with something like that, you can build a program like this one, which is not very different from the one we saw before, right? But now when I hover on... Oh, sorry, didn't mean to do that. But you can see that it automatically creates in memory this idea of what a guitar is. It knows what A minor is. It tries to go through all the possible ways you could play A minor on a real guitar, and then it chooses the one that is best for you as a guitarist. And also uses this little JavaScript library to actually synthesize the sound. Cool. And for example, like once you have that, then like it's super easy to write a program that plays ukulele. And you can see it's like literally 50 lines of code, and 4 lines of code is just like to set the default tuning for an ukulele. So I'm going to need some help here. Cool. Live demo? Yes. So I know that most people are not comfortable singing publicly. So I know you know the chorus. And if you're comfortable singing the chorus, that's amazing. If you're not comfortable doing that, you can just whistle, and that's fine too. Yeah? Let's do it. Yeah? Okay, let's go. Some errors are really bad. They can really make you mad. Debugging just makes you swear and curse. When you're chewing on life's gristle, don't grumble, give a whistle, and Elm will help things turn out for the best. And always look on the bright side of types. Always look on the light side of types. If your code seems jolly rotten, there's something you've forgotten. A parenthesis, a bracket, or quote is string. If you're getting a chord dump, don't be silly chunks. Just purse your lips and whistle, that's a thing. And always look on the bright side of types. More whistling. Always look on the light side of types. For code is quite absurd, and that's the final word. You must always face the curtain with a bow. Even if you're stuck in Vim, give the audience a grin. Enjoy it, your last chance anyhow. So always look on the bright side of maths. Just before you reach your last side effects. My life is in a tweet, when you look at it. Laugh's a laugh, and that's the joke is true. You'll see it's all a show, but please stop writing go. Just remember that the last life is on you. And always look on the bright side of types. Always always look on the light side of types. And always look on the bright side of types. Always look on the light side of types. Thank you. So I promised you the slides, so you can find the library there, all the slides are there, and the 2 demo apps, you can play them online. So for example, like it's the same as I showed you, so there's the code on the left-hand side. So, if you want to change something, you can just change, some errors, becomes some mistakes, and you can just press compile, and it will recompile, and you can play around with it, and, see how it's been done. And yeah, thank you so much.